As part of the A+ College Ready curriculum, we have practice problems that are set up in a PowerPoint form for you to use as either bell ringer exercises, review, or reinforcement exercises. So here's an example in Unit 7 of Solutions to Stoichiometry practice problems. Here's our practice problem 1 set. Notice in number 1 the calculation of the concentration of the ions present in each of the following solutions for strong electrolytes. So this would be a reinforcement exercise that you can have your students be in partner pairing groups, time them, give them about 10 minutes or 5 minutes when you're doing your attendance and checking students' makeup work, calling them up, regardless, your logistics at the beginning of your class. So this would probably be a before activity for a lesson that day as a practice from the day before. So take a moment, work these problems, and I'll come back with you for their answers. So take a moment, check your answers for A, B, and C. Now, as a teacher, the answers to this practice problem is in the teacher notes listed for each slide. So what you could do is you can freeze the slide up on your screen, present this to them, copy this into a quiz, a Google form, just however you want to utilize this. And then at a couple of minutes, take time and debrief it, either through a whiteboarding exercise or have them check their answers, just for a self-assessment of the students. Notice in the problem 2 set, this builds on the concept from problem 1. So in this question is, which of the following solutions of strong electrolytes contain the largest number of molecules or moles of chlorine ions? So we're looking for moles of chlorine ions. So of course, they're giving a volume and a molarity of each substance of aluminum chloride, magnesium chloride, and sodium chloride. So obviously, you've already shown the students to this point with some practice that they'll have to calculate the moles of each. So take a moment for yourself and work through these problems, and I'll come back with you with the answers. Now, a common misconception that most students will have is that they'll calculate the aluminum chloride, the magnesium chloride, and say that those both have the same number of moles, therefore they're equal, therefore sodium chloride. Well, but they forget that the subscript of the chlorine has to be added or multiplied to the moles. And so that's where I remind my students. So that's kind of a misconception that I typically see with my students is they forget that last step of multiplying the subscript of the number of ions of chlorine in the compound. So hopefully you've had this problem as well. You kind of understand that, and then you can address that with your students. If I show them that early on, most of my students will not make that mistake, but you'll still, even at this point, have this. So don't use this as a formative assessment in terms of a formal grade, but use it in terms of a re-teaching moment and as a self-assessment for your students before they have this kind of concept on a summative assessment of some kind. Now notice in problem 3, this equation below. So now we're using an equation. They're going to have to not only convert into moles, but then they're going to have to convert moles to grams. And so notice in the question how many grams of aluminum are required, but they give them hydrochloric acid in the question. So they're going to have to find moles of hydrochloric acid, then do a mole-to-mole ratio of the hydrochloric acid to the moles of aluminum, and then do a conversion factor of moles of aluminum to the grams of aluminum. So take a moment, work it out. We'll come back with the answer, and I'll talk about what I see with my students. So as you can see in this 3-step multi-phase problem, first the students will have to convert to moles. Then once they have the moles of the hydrochloric acid, then they'll compare the moles of hydrochloric acid to the moles of aluminum, and then once they found the moles of the aluminum, then they'll of course multiply by the molar mass of aluminum to get the grains of aluminum. So this is a reteaching moment, a scaffolding moment of some stoichiometry that we had already covered in a previous unit in Unit 5. So this is a great problem to bring that back in. And finally, problem number 4 is similar to problem 3, but it also builds upon that concept of reaction stoichiometry. So again, in the problem, they're given a volume, they're given a molarity of silver nitrate, and it is added to this excess of potassium chloride. And then they want to know in the problem how many grams of silver chloride can be formed. Now, the key terminology here that we see is, of course, excess. So this is kind of invoking that limiting reactant problem for the students, and you can refer back to that you have covered in our previous unit of reaction stoichiometry. So take a moment, work the problem out, and I'll come back with you with the answers. So now that you've worked out the problem, again, this is where that reteaching moment comes into play. Now turn into your teacher hat, if you will, and think about how you're going to address this with your students. So now they should be very comfortable with identifying that they have to multiply the molarity times the volume, but make sure that volume is converted to liters, of course. And then they solve for the moles of the silver nitrate. Now, with that wording, that excess KCl, obviously have them identify and recognize that again, oh, okay, so silver nitrate is the only reactant, that would be our limiting reactant. And you can bring up that terminology again. So then, of course, if the ratio is 1:1, the moles will be the same. So now you'll have the moles of your silver nitrate is equal to the moles of your silver chloride. And then you're just going to multiply by the molar mass of the silver chloride to get the 9.7 grams of your product of silver chloride. So this again is a step-by-step series of problems. So incorporate this as you're going through the lesson of solutions, but this is reteaching that stoichiometry that they've learned, so that way they can impact all aspects of grams to moles, moles to grams, grams to atoms, atoms to grams. We've already gone through their gas unit of going from grams to liters of a gas at standard conditions at STP. And now we're taking in that last component of our mole calculations of going from grams to moles and moles to grams. So this is a wonderful series of practice problems. Hope you use these in your classroom setting in terms of either a bell ringer or an after lesson reteaching moment.